All right, hi folks, this is Larry Mastino. I'm recording a video for MATH022, and I wanted to go over some topics from Objective 7. And this has to do with finding slopes of lines. So let's get started and do a few topics. Let me come to this topic that asks you to classify the slopes based on what the line looks like. Well, first, what is slope? Well, when we have a line, we'd like to know how slanted or how steep the line is. So slope is going to measure the steepness of a line. So slope is a number that measures how steep a line is. Let me take this red line. I'm just going to make up a slope. I'm going to say here the slope is 2. Now we use the letter M for slope, so I could write M equal 2. What if I had a line that was much steeper like this? Well, this slope would be a larger number. The slope might be 10, let's say. What if I had a line going downhill? When the line is going downhill, the slope is a negative number, so this slope might be -9. If I have a line that's exactly horizontal, a flat line going straight across like this slope is 0. And if I have a vertical line, a line going straight up and down, this slope is undefined. Okay, so if a line goes uphill like this, it's going to be a positive slope. So for this line here in this diagram, because it's going uphill from left to right, we would say it's positive. If a line is going downhill from left to right, this is going to be a negative slope. So for this graph that's going downhill, this would be a negative slope. If a line is exactly horizontal like this slope, its slope, like this line, its slope is 0. So a horizontal line has a slope 0. A vertical line has an undefined slope. All right, so that's the background on getting started with slopes. All right, let's do another topic. All right, well, this one's asking us to find the slope based on looking at 2 points on the line. Now, first, for this, we need the definition of slope. The definition of slope of a line is look at the change in the vertical distance between the 2 points and divide it by the change in the horizontal distance. Let me show you what I mean by this. Notice that we're going to set a slope up to be a fraction. What I'm going to do is find out how much distance there is in the vertical direction from this red dot to this red dot. Let me go walk up from here to here. If I walk up, I'm walking up 1, 2, 3 spaces. So the vertical distance between these 2 red dots is 3. All right, how about the horizontal distance between these 2 dots? All right, well, I'm going to go 1, 2 horizontally. So I just went horizontally 2. So this slope is 3/2. All right, so again, what you do is you ask yourself how to go from one to another, how far did you go vertically? And then how far did you go horizontally? This vertical number goes on the top of the fraction, this horizontal distance goes on the bottom of the fraction. All right, let's do a few more examples like that. All right. Now, for this one, they're asking us to actually find the slope based on the XY values of the points. All right, well, let me go ahead and plot these. I just want to get a sense of what these points look like. So let's see, -3, 7 would be up here somewhere, and 2, -6 would be way down here. Well, I can see that this line is going downhill. I should have a negative slope. All right, well, here's the way to find the slope if you're given 2 points. The formula is y⁻² minus y⁻1 over x⁻² minus x⁻1. What this means is you take each one of these xy points and label them. I'm going to call this x⁻1, and I'll call this value y⁻1. And then I'm going to call this value x⁻² and call that y⁻². So it's like I'm thinking of this as the first point, and I'm thinking of this as the second point. That's why we label them with the subscripts in order to distinguish between the first point and the second point. Well, now all I have to do is go plug into this formula. By the way, you don't have to memorize this formula. This formula is available to you in the reference packet. Okay? All right, let's take a look at the y2 value. Well, our y2 value is -6 here. All right, the formula says subtract the y1 value. Our y1 value was a 7. We go to the bottom of the fraction. It says go and get the x2 value. Our x2 value is the number 2, and subtract the x1 value, which is a -3. All right, well, I got to be a little careful with this because on the bottom, when you subtract a negative, I'm subtracting a -3. When you subtract negative, it actually flips to be a positive. All right, well, on top, -6 subtract 7 is -13. On the bottom, -2 plus 3 is a 1. And I could just simplify this to be -13. So the slope of this line is -13. It is a negative slope, which is what I was expecting, because when I did my graph, I noticed the line was going downhill. It should be a negative slope, and it was a negative slope. If my answer came out to be a positive number, I would know that I made a mistake somewhere, and I would want to go back and double check. All right, let's do some more slope problems. All right, how about finding the slope of the horizontal and vertical line? All right, well, why don't we do this 2 ways? Let's graph the line. So let's do part A, and then we'll do part B. Part A, let me graph these points. I just want to get a sense of what this line looks like. Well, it says 8, 5. That means go over 8 and up 5. So that'll be a point here somewhere. Then it says -8, 5. Well, -8 is back here, and +5 would be here. So I can see this is a horizontal line. Well, I know a horizontal line has a slope of 0. But let's work it out using the slope formula just to see that that really is correct. So I'm going to do the slope is y2 minus y1 over x2 minus x1. I'll label these points. I'll call this x1, y1, and x2, y2. All right, so let me plug in. The slope is going to be y2, which is 5, minus y1, which is also 5, over x2, which is -8, subtract x1, which is +8. Well, when I work this out, I'm getting a 0 on top and a -16 on the bottom, but 0 divided by any number is 0. So the answer for part A is the slope is 0. Again, when I graphed it and I saw the horizontal line, I knew the slope would end up being 0 because the slope of any horizontal line is always 0. Let's go to part B. Let's graph part B. All right, -6, -7 is down here somewhere. And then 5, -7, 5, -7 is down here somewhere. And again, I can see this is going to be a horizontal line. So the slope here is going to be 0. Again, if I wanted to plug into the slope formula, be y2 minus y1 over x2 minus x1. Here's x1, here's y1, here's x2, here's y2. I'll go plug in. y2 is -7, subtract y1. y1 is also -7 over x2, which is 5, and x1 is -6. Well, remember, we'd like to clean up when you subtract a negative, because that flips it to be a positive. So I'm going to write this as -7 plus 7. And on the bottom, it's going to be 5 plus 6. Well, this is 0 over 11, but that's 0. So just a reminder, the slope of any horizontal line is 0. The slope of any vertical line is undefined. This info and this formula for slope are all in the reference packet. So if you forget any of this, be sure to go back and check out the reference packet. All right. How about if they want us to graph a line using a slope and y-intercept. All right, well, here's what I could do. The first thing is, whenever they tell me a y-intercept of -2, that means I know the graph crosses through this point -2 on the y-axis. So I can immediately put that red dot there to represent the y-intercept of -2. All right, let me take the slope. The slope they're telling me is 3. But I like to write slope as a fraction. So I'm going to write it as 3/1. Well, remember, the top number is the vertical distance to go, and the bottom number is the horizontal distance to go. So really, the slope is telling me go up 3 and over to the right 1. So I'm going to start here at this y-intercept. I'm going to go up 3. So up 1, 2, 3, and over to the right 1. That's going to put another blue dot there. So I went up 3 and over 1. Put this other blue dot here is the line I'm interested in. All right, so to graph a line like this, when you know the slope and y-intercept, first plot the y-intercept. That's always going to be a point on the y-axis. Then use the slope as directions to get to the second point. The top of the fraction is the vertical distance to go. The bottom of the fraction is the horizontal distance to go. If this top number was negative, let's say it was -3. Well, instead of going up 3, I would be going down 3, right? So if the top number is a negative number, it means instead of going up, you should go down. All right. Let's do another similar example here. All right. So here's an example that says graph a line that has a slope -3/4 and passes through this point 4, -1. Well, if it passes through the point 4, -1, I can go plot that point right away. So let me go plot that point. I'm going to go over 4 and down -1. So here is the point 4, -1. I know the graph has to go through that point. Now I'm going to use a slope as directions on how to get to the second point. Now, when you have a negative sign in front of a fraction like this, it's better to take that negative sign and assign it to the top number like that. So I'm going to take that negative sign and move it up to the numerator and make it -3/4. All right, well, I know the top number is the vertical distance to travel. The bottom number is the horizontal. But the top number is a -3. That means go down 3, go down, whoops, go down 3, and then go over to the right 4. All right, so I'm going to do that for our point here. I'm going to go down 3 units. 1, 2, 3. Let's say it's 1, 2, 3. So I just went down 3. Now I'm going to go over to the right 4. 1, 2, 3, 4 units right there. And I'm going to put a second dot. So I use the slope to get me a second point. The slope was -3/4. The -3 says go down 3. So I went down 3 and then go over to the right 4. Here's the red dot. Connect these 2 points. That should be graph of the line. Notice how this line goes downhill, and notice how the slope is negative. That makes sense. Remember, if the slope is negative, the line should be going downhill from left to right. All right, let's do a couple more. How about, let me take a look here. It says write an equation for the line that has a slope of 1/5 and a y-intercept of 2. Well, notice this problem says use what's called slope-intercept form. Well, slope-intercept form is y equals mx plus b. M is the slope of the line, and b is the y-intercept of the line. This equation is in the reference packet. Well, they're giving me the slope. They're telling me the slope is 1/5. So I'm going to replace m with 1/5. And they're giving me the y-intercept is -2. I could write this as plus -2 like that if I wanted to. This answer is okay. I can also write this answer as 1/5 x minus 2. That answer is okay also. So adding a negative number is really the same as subtracting that number. So either one of these two answers is equally okay. So all we did here is we started out just writing y equals mx plus b, replace m with the slope they gave you, replace b with the y-intercept they gave you, and that's the equation they're asking me for. All right, let's do an example of finding slopes. All right. All right, I just want to get an example that will be useful to us. All right, let's do this one. All right, now they're giving me this equation that says y equals 4/3 x. Now, they're going to ask me for the slope of a line parallel to this line. Well, here's an important fact about parallel lines. Parallel lines have the same slopes. And if you think about it, a parallel line has the same steepness. You know, if these two lines are parallel, they have the same steepness. So let's say this slope was 5. This slope would be 5. So parallel lines always have the same steepness. So if this is the original line they're giving me, and I compare this to y equals mx plus b, I notice, by the way, I can write this as 4/3 x plus 0 if I wanted to, but I notice the slope is 4/3. So if the slope of the original line is 4/3, then the slope of a parallel line also has to be 4/3. Because remember, parallel lines always have the same slopes. So the answer to part A is 4/3. All right, let's go to part B. Part B says, what's the slope of a line perpendicular? Well, perpendicular lines have slopes that are negative reciprocals of each other. So let's figure out what this is really telling us. Well, negative means a different sign. Reciprocal means flip the fraction upside down. All right, so let's take a look at this. The original slope they gave us was 4/3. All right, I want to get the slope of a perpendicular line now. Well, I have to make it negative, so I'm going to make it a negative, and I have to make it a reciprocal. A reciprocal means flip upside down. So instead of 4/3, I'm flipping it to be -3/4. And remember what a perpendicular line looks like. A perpendicular line is a line that crosses at a right angle like this. And it makes sense that if one of these lines has a positive slope, the other line should be negative. You can see how these lines are moving in opposite directions. So if one slope is positive, the other is going to be negative. So the answer to part B here is -3/4 because we had to make the slope negative of the original slope and we had to flip the slope upside down. All right, folks, hope this is helpful as you're working in Objective 7.